Hi, this video is about the truth about Retrieval Augmented Generation, otherwise known about RAG. My name is David Hood, and I'm CEO of 42 Robots AI, where we help organizations implement AI. And part of the point of this video is that there is a massive amount of unexpected nuance here. I hear a lot of people talk about, oh, you use RAG, cool. They kind of like check that box, I get how you're doing it. But based upon our experiments and our use cases, there is a lot of different things to consider, a lot of different ways to do this. This is not just a, okay, using RAG, I know what you're doing type of scenario. So let's get into it. So first, in case you don't know, what is RAG? It's Retrieval Augmented Generation, and it's where you're retrieving something to put into the context window for a large language model to help it augment the generation. It's essentially what it means. Very, very useful. One of the most common things to retrieve from is a vector database, where essentially what you'll do is a user, you have a vector database where you've kind of broken up a data set into smaller pieces and you throw it into a vector database. All right, let's say you've got 10,000 items in there. You don't want to put all of those in the context window. So a user comes in and gives a request. What you do is you use the semantic meaning of the words that has been turned into math in order to sort the vector database by the most semantically relevant items in there. You take the top X, maybe like 5, maybe 7, maybe 3, depending on the scenario, and you put it into the context window, and it dramatically improves the output. Okay. Now it's not always vector databases. Maybe it's web search. There's other forms of retrieving things, but most commonly it's a vector database. That's just the most common use case, and that's usually what somebody means when they're using RAG. But there's a lot more nuance to this. It sounds pretty simple, and it can be used actually quite simply, pretty effectively. But as you get to more complex, more useful, more specific use cases where you need your results need to be more reliable, and what you retrieve needs to be more reliable, things can get a little bit more complicated. Let's just talk real quick about why this helps. Oops. So essentially what you could do is, there was an example. Let's give a really simple one. I met this guy who has 300,000 plus sample conversations of automotive customer support. And what you could do is you could train the model, or pre-train or post-train, or fine-tune a model or whatever to try to get it to answer the questions you want. And to where it comes in and the user gives an input and you just one-shot response. So that one shot just means that there's no samples given. But what you could also do, and what we're working on talking about with him is, okay, let's take, of those 300,000 conversations, let's take the most relevant ones that were good, and let's put those into the context window as samples. And so this should, especially if there's like a similar question that's been asked like 5 times, and that the rep in the manual scenario has answered correctly, it really dramatically will improve the reliability of the output. And so you're essentially turning something from one shot into multiple shot. Or it could just be relevant context. Let's say you've got a 10,000 pages of legal documents, and you're trying to answer a legal question, and you want to pull out the most relevant chunks of those legal documents, then you can put the most relevant context into there. This gives you more control over the outputs, essentially, quite a bit, versus depending on either what's already in the data set for the LLM or fine-tuning it to meet your data sets, which is not quite what fine-tuning is really intended to do anyways. Now, here's where it gets pretty complicated. And this is why, essentially why I made this video, because I don't see anybody talking about all the different nuances and all the different ways in which, if you're going to do this really well and professionally, then all of these things need to be considered. So first of all, how do you chunk it? So let's say you've got the 10,000 pages of legal documents, for example. How do you chunk it? Do you do it in, each document is 10 pages? Do you just do every document as a single one? Well, that's going to be probably too big, not reasonable for your context windows. Okay, so you're going to have to break up the 10,000 page, the 10 pages into what? Paragraphs? Pages? Is there going to be overlap? Is it just straight up characters? And then also, what are some of the thresholds? So it's not just about, okay, maybe it's, again, paragraphs is sort of like a threshold, like a new line. or is there some other sort of threshold in there? These are non-trivial questions because they can significantly affect what is retrieved and also and therefore the responses you get from the LLMs. And my quick suggestion for this is you definitely don't want these to be too big or too small. There's a balance here, and it depends on your use case as to what the right amount is. If you think about it, if you did do all 10-page documents, there's going to be a lot of stuff in there that's not really relevant to a specific question, probably. So you probably don't want to do that. But you also probably don't want to do like single sentences, because oftentimes a sentence doesn't live by itself. It lives within a context. Probably one of my favorite ones is something like an n number of paragraphs. So maybe it's one. Maybe it's like 5, but with one paragraph overlap, so that there's different contexts that are given. There's a bunch of different ways to do this, and there's not like a single right way. Again, just try to be balanced. Also, when you're putting the data into the RAG database, is there some processing of it? And one of our things, what we do is we actually do pre-process it before we put it into there. We actually essentially compress the data. And so as a result, when we pull it out, it takes up less space, but has essentially the same semantic meaning. There's a whole bunch of other ways that you can pre-process it. Maybe actually you split the data up into 2 different databases, and one of them is meant to be kind of more raw, and one of them is like a processed version of it where you're extracting certain types of information. There's a ton of different ways to do that. So also, when you're storing it in a vector database, which service do you use? Which semantic similarity calculation to use? There are actually different mathematical calculations that you use. Now, there's one most commonly used that's kind of agreed upon as the best one, but which one do you pick? Maybe this changes your results. It depends on your scenario. Which embedding model do you use? It's not trivial which embedding model you use. The main one that I use is OpenAI's Ada, and so that's one of the most common ones and simple, but it's not perfect. I've run some tests on its semantic similarities, and it doesn't always get it right. So perhaps there are some embedding models that are more useful to your specific use cases, and that's something that should be considered, especially if you're finding that there's not really good relevance. So how do you grab out of the vector database? What do you grab? What do you actually retrieve? Is it what quantity of it? So do you grab 3, 5, 7, 10? How many pieces from, let's say you're pulling from a vector database, how many pieces do you pull from there? Let's say you're doing a web search. Do you pull the whole web page? Do you chunk it up into pieces and do you grab some of those pieces? What do you grab? What are the similarity thresholds? Sometimes what you can do is, I grab 5 pieces, but they have to meet a certain threshold of similarity. So sometimes you're actually grabbing less than that because some of the ones are not quite as relevant. Well, that creates some problems potentially. What if you grab nothing? What's the right threshold for that? That's going to require some testing. And then is there some post-processing? So after you've pulled the data in the retrievals, is there some post-processing? Do you want to expand it? Do you want to merge it with some other data? Do you want to compress it even further? There's a bunch of different stuff that you can do here that can dramatically affect the outputs. Where do you put the retrievals within the prompt? All these next 3 are about the prompt. How do you frame them in the prompt? What else is in your prompt? All of these things matter. And so when it comes to, I'm doing Retrieval Augmented Generation, cool, RAG, I get it, what you're doing. There's so many decisions to make here to where it's kind of surprising to me that maybe it's, I think it's because there's a lot of people who have studied up on it but not actually used it in real world scenarios, and so this isn't something they've encountered. Well, we've encountered it because we've used this a bunch of different ways and tested a whole bunch of different stuff. And there's not one answer here. It kind of depends on your scenario. Some things are better than others. So there's a lot of tools out there like LangChain and Llama Index and other ones. I really respect what these people are doing. They're in a very important space, which is essentially they are looking at how to leverage LLMs as an organization. So before I move on, if you're liking this video, if you think it's valuable, please like and subscribe. Or if you have any questions or comments, please leave a comment below. It really helps spread the word on some of these things that are really important but that are not commonly out there. So part of the challenge here, the thing with these types of tools is it can feel really good because they're like, in 3 lines of code you can set up a RAG database or you can build an AI agent. But the problem is there's a distinct lack of clarity when it comes to what is exactly happening. It's pretty hard to like, okay, so I'm using their RAG database. What actually is happening? All of this stuff up here, what decisions are they making? Because they're making these decisions for you. Some of them you can't even flip the switch. Some of them, maybe there's a default and then you can update it. But even just figuring out exactly how they're doing it, the nuance, the order of operations of how they're doing all these things matters. And so there's a really, it's pretty challenging just to kind of navigate through somebody's massive code set. Because it's not just like a simple thing. Now, you devote somebody enough of your time to it, then that makes sense. But in that sense, it's like, to me at least, it's faster and better for me to just make it my own way from scratch, and then that way I can understand it, or with somebody within my organization, we have somebody there who can kind of address what's really happening and flip some switches or add some switches or some kind of knobs and dials for things that we want. Not all the knobs and dials that you want are going to be in these. It's just not. It's not made for you. And so that's where being able to tune it for your specific use case so you get the higher quality results, your ability to do that is much more limited with these shortcut tools. So I don't recommend using these tools unless it's like very early proof of concept, and even as quickly as possible you want to make your way to building this yourself. Okay, so let's just kind of cover a little bit more high level things in terms of adding complexity. So there's a lot. This goes back to the kind of the bad AI architecture where they put the LLM at the center, and then RAG is just kind of like a little tool on the side to help augment it. But really, the better way to do this is to put this within a bigger solution, to where you're using LLMs to solve key problems, and then at those LLM steps, you're using Retrieval Augmented Generation. Or sometimes you're also, like along the way, you're building some stuff to put into the context window. So you're just doing other data processing that goes in. It's not really retrieving it, but it's still putting it in the context window. One thing I alluded to before was re-ranking. Sometimes what you want to do, and this can be very effective, is you pull a lot off of the top. So let's say you got 10,000 records, and you pull off like 100, and then you use another ranking or sorting or filtering algorithm on top of that. So you take those 100 that are most relevant, and then you want to, let's say, do a keyword search, or you want to do something for, you want the longer or the shorter ones, or there's some metadata on each one that you want to filter for. Like maybe you want to filter for date, so you want something that's recent or old. There's a whole bunch of different ways to kind of re-rank afterwards. This is incredibly useful. Multi-layer. So our long-term memory is not just one. The RAG database has some additional like user-based global data that helps filter and or support the RAG. It's hard to explain super clearly, but sometimes you can have like a RAG that's essentially multiple layers. It's not the same thing as re-ranking, but you can actually have different parts to the retrieval. And it's not necessarily two different RAGs, which is what I'm saying here. Sometimes you have 2 or 3 different data sources and you want to pull from both of those or all of those. And so you have multiple sets of context. So this dramatically improves the value, the outputs if it's needed, and there's valuable information there. I could go on, but I think hopefully that helps understand really the truth about Retrieval Augmented Generation, and that it's not just as simple as people want it to seem on the surface. There is a lot of nuance and a lot of choices that you can make to dramatically improve the usefulness of it. So if you found this useful and you want to help your organization implement AI, you can get a free custom AI implementation roadmap by calling this number or clicking the link below to schedule something with us. Thank you very much, and please like this video. Let me know what you think. Do you disagree with me? Is there anything else in here that I missed? Please let me know. Thanks, and have a great day. Bye.